Okay, 25. 25 against multiplication to matrix. Okay, analyze the dimension matching perfectly. We have here 2 column and we have here 2 row. 2 column, 2 row. And the new matrix would be 2 by 4. So let's do the multiplication. Multiplication, first row and first column. 2 times 2 is 4 minus 6. The answer is -2. Now second column is 2 minus is plus 2 is 4. Okay, now next one is 8 and -6 is 2. Okay. Okay, next is 12. 2 times 6 is 12, and -2 is -2 and +2 is -4, so it's 8. Now second row and the first column is 2 plus 0 is just 2. This and this is 1 and 0 is gone. This one. The other is 4 and 0 is 4. And the other is 6 and 0 is 6. And the final answer is -2, 4, 2, 8, 2, 1, 4, and 6. And the matrix is 2 by 4. Let's check with the calculator. In the calculator, I have the matrix A edit, so I skip this step. This is matrix A, 2, -2, 1, 0, and the matrix B is 2, 1, 4, 6, 3, -1, 3, and 2. Now let's do the multiplication. Multiplication A times B. And the answer is -2, 4, 2, 8, 2, 1, 4, 6. Perfect. Okay, 27. 27 is again multiplication of the matrix. The first matrix 2 by 3 and the second one 3 by 2. The dimension matching very well. The answer would be then matrix 2 by 2. Let's do it by hand and after checking with the calculator. This is multiplication row 1 and column 1. This is 1 times 1 is 1 minus 2 plus 6. The answer is 1 minus 2 and -1 plus 6 is 5. Okay, that was this times that. I don't know, this times the second is 2, is 0, is 12. Entonces 14. Okay, now second row and the first column is 0, is plus 1, and this is 8. Entonces the answer is 9. And the last one is 0 plus another 0 plus 16. The answer is 16. And the answer is 5, 14, 9, and 16. Is 2 by 2 matrix. Using the calculator, I have the matrix A is this one, and the matrix B is this, A and B. Okay, now there the multiplication. Multiplication A times B. 14, 9, and 16. Okay, 29 again is multiplication to matrix. In this case, matching very well the dimension, and the answer is 3 by 2. Let's do the multiplication. This multiplied by that. 1 times 1 is 1, plus 0, plus 8. The answer is 9. Now the second is 3 plus 0 minus 1. The answer is 2. Now the second multiplied by the first column is 2 plus 24 plus 8. The answer is 34. Now by the second column is 6, 2 times 3 is 6, plus 8 minus 1, 13. Now the third row in the first column is 3 plus 36 plus 8. The answer is 47. And the last is 3 times 3 is 9, plus 12 minus 1 is 20. The answer is, the matrix is 9, 2, 34, 13, 47, and 20. Yes, 3 by 2. That's the answer. 3 by 2. Now checking using the calculator. Okay, in the calculator, for example, the matrix A, I did before, is this matrix. And the matrix B is this matrix. And the multiplication both in this order, A times B is this answer. 9, 2, 34, 13, 47, and 20. Perfect. Okay, 31 is determine si the matrix A is non-singular, and si es non-singular, find the inverse of the matrix. Ok, entonces non-singular matrix is a matrix in which the determinant is different to the 0. Now let's compute the determinant. The determinant of the 2, 1, 1, 1 is equal, let's see, the rule is plus here and minus here, multiplication. This is 2 minus 1, of course 1 is different to the 0, therefore it's non-singular, and the inverse exists. Okay, so now in 2 by 2 problem, it's much better, in my opinion, using the cofactor formula. So the inverse matrix is equal to the adjoint of A divided by determinant of A. And adjoint of the A is the cofactor transpose formula. Let's find the cofactor. The cofactor is extremely easy in 2 by 2 because suppose this is the matrix 2, 1, 1, 1, is the original matrix, and you determine the cofactor. The cofactor here is 1, and the cofactor 1, 1. This is the cofactor 1, 1 is equal 1. Let me copy. The cofactor 1, 2 is this, is equal 1 again. But in this case, remember the sign is minus 1. When you add in this is 1 plus 2 is 3, because odd number is negative. And when you add 1 plus 1 is 2, because even number is positive. Okay, the cofactor 2, 1. The cofactor 2, 1 is, let me copy the original matrix. 2, 1 is here. It's 1 again. It's 1, pero negative 1. So cofactor 1, 2, 2, 1, sorry, is negative 1. And finally, cofactor 2, 2. Cofactor 2, 2 is see this and this is 2. In this case possible because 2 plus 2 is even. Cofactor 2 is equal 2. Also now the cofactor matrix is 1, negative 1, negative 1, and 2. Okay, so one important conclusion is, look, the shortcut to do super fast the cofactor matrix is, for example, this is the original matrix, you swap the main diagonal 2 and 1, and you interchange this, swap again 1 and 1, and you change the sign, a negative both, or opposite sign in general, and you get the cofactor matrix. Okay, entonces the cofactor transpose is you change the column by the row. In this case the column 1 is 1, negative 1, entonces I change to 1, negative 1. In this case the column 2 is negative 1, I change to negative 1 and 2. It stays the same. What is the reason it stays the same? Because this matrix is symmetric matrix. So now this is the main diagonal, and you flip it around, the main diagonal stays the same because it's negative 1 and negative 1. So the transpose is the same to the original. So the transpose is the same to the original when the symmetric matrix. Okay? And finally, divided by determinant, but the determinant in our example is 1, so it stays the same. Now finally, inverse matrix is 1, negative 1, minus 1, and 2. Okay? This is the final answer. Alright, now, I want to make sure. Now let me copy the inverse here. The inverse is the inverse is 1, negative 1, negative 1, and 2. Okay, to make sure everything is okay, let's do in the multiplication the original matrix time is inverse in different order. And I suppose in this case you must get the identity matrix. So let's do the multiplication. A times A inverse. So is 2, 1, 1, 1 times 1, negative 1, negative 1, and 2. It's obvious that matching very well the dimension because it's a square matrix. It's 2 by 2 and we expect 2 by 2. 2 by 2. Multiplication. This times this is 2 minus 1. Obviously is 1. By the second is minus 2 plus 2 is 0. The second row is 1 and negative 1 is 0. And finally is negative 1 plus 2, okay, obviously is 1, and we get the identity matrix of the dimension 2. So this is equivalent symbolic identity 2. Likewise, when you multiply in different order, in general it's not the same, but in this case, yes, it's the same particular case. Suppose inverse is 1, negative 1, negative 1, 2, and 1, negative 1, negative 1, 2. No. The original. And the original is the original is 2, 1, 1, and 1. Let's do it. 2 by 2 again is 2 minus 1. Obviously is 1. Is 1 minus 1. S0. This is negative 2 and plus 2, S0. And this is negative 1 plus 2, S1. Again, we get the same answer. Identity matrix of the dimension 2. Identity 2. Okay, super fantastic example.